Algebra inequalities, functions, quadratic equation and polynomials. Explain algebraic inequalities and algebraic functions. Algebraic inequalities and algebraic functions are two important concepts in algebra. Algebraic inequalities. An algebraic inequality is a mathematical expression that compares two algebraic expressions using a relation symbol such as greater than, equals, greater than or equal to. An example of an algebraic inequality is 2x plus 3 less than 7x, 5. This inequality compares the expression 2x plus 3 to the expression 7x, 5, and the symbol means that the left-hand side is less than the right-hand side. We can solve this inequality by isolating the variable x on one side of the inequality. 2x 7x less than minus 5 to 3. 5x less than minus 8. X greater than 8/5. So the solution to the inequality is x greater than 8/5. This means that any value of x greater than 8/5 will make the inequality true. Algebraic functions. An algebraic function is a mathematical rule that assigns a unique output value to each input value. Algebraic functions can be represented using algebraic expressions, graphs, and tables. An example of an algebraic function is f(x) equals 2x plus 1. This function takes an input value of x and outputs a value equal to twice x plus 1. We can evaluate the function at a particular value of x, such as x equals 3, by plugging in the value and simplifying. f3 equals 2 3 plus 1. f3 equals 7. So the value of the function at x equals 3 is 7. We can also graph the function by plotting points on a coordinate plane. The graph of the function f(x) equals 2x plus 1 is a straight line with a slope of 2 and a y-intercept of 1. Anything more I need to know before we go on? What is meant by discriminant? Before we move on, it's important to know that the discriminant is a term used in the quadratic formula to determine the nature of the roots of a quadratic equation. In algebra, a quadratic equation is an equation of the form ax squared plus bx plus c equals 0, where a, b, and c are constants and x is the variable. The quadratic formula is a formula that gives the solutions to a quadratic equation. The quadratic formula is x equals b plus or minus sqrt b squared, 4 acres, 2a. The term b squared, 4 acres inside the square root is called the discriminant. The discriminant can be used to determine whether the quadratic equation has two real roots, one real root, or two complex roots. If the discriminant is positive, b squared, 4 acres greater than 0, then the quadratic equation has two real roots. If the discriminant is 0, b squared, 4 acres equals 0, then the quadratic equation has one real root, which is also called a double root. If the discriminant is negative, b squared, 4 acres less than 0, then the quadratic equation has two complex roots, which are complex conjugates of each other. Knowing the value of the discriminant can help us determine the nature of the roots of a quadratic equation without actually solving the equation. Okay, let's move on to polynomials. Sure, let's talk about polynomials. In algebra, a polynomial is a mathematical expression that consists of variables and coefficients, and involves only the operations of addition, subtraction, multiplication, and non-negative integer exponents. The general form of a polynomial is a underscore nx to the power of n plus a underscore n1, x n1, plus a underscore 1x plus a underscore 0. Where a underscore n, a underscore n1, a underscore 1, a underscore 0 are constants called the coefficients of the polynomial, x is the variable, and n is a non-negative integer called the degree of the polynomial. For example, the polynomial 3x squared, 5x plus 2, has degree 2 because the highest power of x in the polynomial is 2. The coefficients of the polynomial are 3, -5, and 2. Polynomials can be added, subtracted, and multiplied like any other algebraic expressions. When multiplying polynomials, we can use the distributive property to multiply each term in one polynomial by each term in the other polynomial, and then combine like terms. Polynomials can also be factored, which means that we can write the polynomial as a product of simpler polynomials. For example, the polynomial x squared, 5x plus 6, can be factored as x, 2x, 3. We can check this by using the distributive property. X, 2x, 3, equals xx, 3, 2x, 3, equals x squared, 3x, 2x plus 6 equals x squared, 5x plus 6. Factoring polynomials is an important skill in algebra, as it can help us solve equations and simplify expressions. Explain non-negative integer exponents and distributive property. Non-negative integer exponents refer to the way variables are raised to powers in algebraic expressions. An exponent is a small number written above and to the right of a variable, which indicates how many times the variable is to be multiplied by itself. For example, in the expression x cubed, the variable x is being raised to the power of 3, which means we are multiplying x by itself 3 times, xxx. The result is a new term in the expression that represents the product of x raised to the power of 3. Non-negative integer exponents mean that the exponent must be a whole number, integer, that is greater than or equal to 0. This means that we can only raise variables to positive powers, or leave them with an exponent of 0, which represents 1. For example, x to the power of 0 is equal to 1, and x squared is equal to xx. The distributive property is a rule in algebra that allows us to simplify expressions by distributing a factor to all terms inside a set of parentheses. Specifically, it says that if we have an expression of the form a b plus c, we can distribute the factor a to the terms inside the parentheses by multiplying it by each term. A b plus c equals ab plus ac. This is true for any value of a, b, and c. The distributive property can also be used in reverse to factor expressions. For example, if we have the expression 2x plus 4, we can factor out the common factor of 2 to get 2x plus 2. This means that 2 is a factor of both 2x and 4, and we can write the expression as a product of 2 and x plus 2. The distributive property is a useful tool in simplifying and manipulating algebraic expressions. Yes, there are a few more things you should know about polynomials. The degree of a polynomial is the highest power of the variable in the polynomial. For example, the polynomial 3x squared, 2x plus 5 has a degree of 2, because the highest power of x is 2. The degree of a polynomial can help us determine the behavior of the polynomial, such as whether it has a maximum or minimum value, or how many roots it has. A polynomial with n distinct roots can be factored into n linear factors. For example, the polynomial x squared, 5x plus 6 has 2 roots, 2 and 3, so it can be factored as x, 2x, 3. This is known as the factor theorem. Synthetic division is a method for dividing one polynomial by another polynomial of lower degree. It is a shortcut method that can make polynomial division faster and easier. It involves using the coefficients of the polynomial and a given divisor to find the quotient and remainder. The fundamental theorem of algebra states that every polynomial equation of degree n has n roots, counting multiplicity. This means that every polynomial of degree n can be factored into n linear factors, which may or may not be real. Understanding these concepts can help you work with polynomials more effectively and solve polynomial equations. Yes, here are a few tips for remembering algebraic concepts. Set aside time to practice solving equations, simplifying expressions, and factoring polynomials. Create visual aids. Draw diagrams or graphs to help you visualize algebraic concepts. For example, you can draw a graph of a quadratic equation to see where the roots or vertex lie. Use mnemonic devices. Mnemonic devices are memory aids that help you remember information by associating it with something else. For example, to remember the quadratic formula, you can use the mnemonic x equals negative b plus or minus the square root of b squared minus 4 acres, all over 2a. Break down complex concepts into smaller parts. If you're struggling to remember a complex equation or concept, try breaking it down into smaller parts and focusing on one part at a time. Don't be afraid to ask a teacher or tutor for help if you're struggling to understand a concept. They can provide additional explanations and examples that may help you remember the concept better. Remembering algebraic concepts takes time and practice, but with persistence and dedication, you can master them. In this equation, what is meant by the underscore a underscore n x to the power of n plus a underscore n1, x n1, plus a underscore 1 x plus a underscore 0. The notation a underscore n x to the power of n plus a underscore n1, x n1, plus a underscore 1 x plus a underscore 0 represents a polynomial function in x of degree n, where a underscore n, a underscore n1, a underscore 1, and a underscore 0 are constants known as the coefficients of the polynomial. The coefficients represent the numerical values that are multiplied by each power of x in the polynomial. The subscript notation, a underscore n, a underscore n1, a underscore 1, a underscore 0, indicates the order of the coefficients in the polynomial, with a underscore n being the coefficient of the highest degree term, x to the power of n, and a underscore 0 being the constant term. For example, the polynomial 3x squared, 2x plus 5 can be written in the form of a underscore n x to the power of n plus a underscore n1, x n1, plus a underscore 1 x plus a underscore 0 as 3x squared, 2x plus 5 equals 3x squared plus, minus 2x to the power of 1 plus 5x to the power of 0. In this case, n equals 2 because the highest degree term is x squared, and the coefficients are a underscore 2 equals 3, a underscore 1 equals minus 2, and a underscore 0 equals 5. Explain factor theorem to us. The factor theorem is a theorem in algebra that states that if a polynomial fx has a root r, then r is a factor of fx. In other words, if fr equals 0, then r is a factor of fx. In mathematical notation, the factor theorem can be expressed as follows. If fr equals 0, then fx equals x, rgx, where gx is another polynomial. The factor theorem can be used to factor polynomials and to find their roots. To use the theorem to find the roots of a polynomial, you can set fx equal to 0 and then solve for x. If you know one root of the polynomial, you can use the factor theorem to find the other roots. For example, consider the polynomial fx equals x cubed, 5x squared plus 8x, 4. We can use the factor theorem to determine if x1 is a factor of fx. We evaluate f1 as follows. f1 equals 1 cubed, 5 1 squared, plus 8 1, 4 equals 0. Since f1 equals 0, the factor theorem tells us that x1 is a factor of fx. We can use long division or synthetic division to find the other factors of fx, which are x2 and x2, again. x cubed, 5x squared plus 8x, 4. x1 equals x squared, 4x plus 4 equals x, 2. Therefore, the roots of fx are x equals 1 and x equals 2, with multiplicity 2. Sure, here's another example of how to use the factor theorem. Let's say we have the polynomial fx equals x to the power of 4, 6x cubed plus 13x squared, 12x plus 4. We want to determine if the factor, x1, is a factor of fx. To do this, we evaluate f1 as follows. f1 equals 1 to the power of 4, 6 1 cubed, plus 13 1 squared, 12 1 plus 4 equals 0. Since f1 equals 0, we know that x1 is a factor of fx. We can use long division or synthetic division to find the other factors of fx. Using synthetic division, we can write 1 minus 6 13 minus 12 4, 1 minus 5 8 minus 4. 1 minus 5 8 minus 4 0. This tells us that fx equals x, 1x cubed, 5x squared plus 8x, 4. So the other roots of fx are the roots of the cubic polynomial x cubed, 5x squared plus 8x, 4. We can use the factor theorem again to check if the factor, x2, is a factor of this cubic polynomial. f2 equals 2 cubed, 5 2 squared, plus 8 2, 4 equals 0. Since f2 equals 0, we know that x2 is a factor of the cubic polynomial. We can use long division or synthetic division to find the other factors of the cubic polynomial, and then find all the roots of the original quartic polynomial fx. Explain more about synthetic division. Synthetic division is a method for dividing a polynomial by a linear factor of the form x, a, where a is a constant. It is a simplified version of polynomial long division and can be used to factor polynomials or find their roots. The basic idea of synthetic division is to represent the coefficients of the polynomial in a special way and perform the division using only arithmetic operations, addition and multiplication. Here's how to perform synthetic division for dividing a polynomial fx by x, a. Write the coefficients of fx in a row, with the powers of x decreasing from left to right. For example, if fx equals 2x cubed plus 3x squared, 5x plus 1, write 2 3 minus 5 1. Write a in the leftmost column, separated by a vertical line. For example, if we want to divide by x, 2, write 2 3 minus 5 1. Bring down the first coefficient, 2 in this case, below the horizontal line. Multiply a by the number below the horizontal line, 2, and write the result in the next column to the right. Add the two numbers in the second column, 3 and 4, and write the result below the horizontal line. Multiply a by the number below the horizontal line, 4, and write the result in the third column to the right. Add the two numbers in the third column, minus 5 and 8, and write the result below the horizontal line. Multiply a by the number below the horizontal line, 8, and write the result in the fourth column to the right. Add the two numbers in the fourth column, 1 and 16, and write the result below the horizontal line. This is the remainder. The quotient is the coefficients in the top row of the table, in order from left to right. In this case, the quotient is 279, and the remainder is 17. Therefore, we have 2x cubed plus 3x squared, 5x plus 1 equals x, 2x squared plus 7x plus 9, plus 17. Synthetic division can be a quicker and easier method than long division, especially for dividing by linear factors of the form x, a. It is important to note that synthetic division only works for dividing by linear factors, and for dividing by other factors we would need to use long division or another method. Like, comment, subscribe, to follow along for the trip.